And there we go. So this is going to be the start of the session. Problem 1 is about vectors. So for the following questions, you will need to draw vectors, place the tail of each vector at the origin, and use the usual coordinates where positive x points to the right. And this represents east, and plus y points up, and this represents north. For some reason, the components aren't showing up here, but they had ax as 7 meters and ay as negative 11 meters. So these are the two components that we're referring to for vector A. And so we need to draw the vector on a diagram and determine the magnitude and direction. I don't know why the problem is cutting off here on the recording, but we just need to draw vector A and determine the magnitude and direction. And when we say direction, right? So direction, I don't know if you guys watched my written homework review session or if you've looked at the lecture slides or anything like that, but when it comes to directions in vectors, there's two components basically. When we want to specify direction of a vector, number one, we got to give some angle, right? Some 30 degree, 40 degree angle, whatever it is, we have to indicate some angle, right? And then the second component is to indicate a direction, right? So we have to say like, and that's going to be like cardinal directions, right? So south, north, east, west. So you have to give some angle and then the corresponding cardinal directions with that angle. Now, we'll draw here a little coordinate plane. I think that's, let me do that again. There we go. Yep, there. So this is y, this is x, and they said positive x points to the right, positive y points up. So we just need to draw this vector, determine the magnitude and direction, and like I said, with the direction, it's an angle, it's cardinal direction. So if I, for example, have this vector pointing this way, right, and this is the angle I want to specify, let's say this is a 30-degree angle, right, then in order to describe this angle with a cardinal direction, I have to describe it based on its location relative to the axes. So imagine this angle right here. I created this angle starting at the y-axis, right? So I grabbed, think of the y-axis as a rod, so I grabbed it, and then I extended it this way, this way, this way, until I make that angle that I'm looking for, right? So I'm moving, in that case, east of the y-axis. So I'm grabbing this y-axis, and I'm moving it in the east direction, or the positive x direction. So therefore, that angle that's sandwiched in between the y-axis and the vector, the angle that's sandwiched in between the y-axis and the vector, that will be named east of north. Now, if the angle that was in question was here, sandwiched in between the x-axis and the vector, right, then that would be north of east. North of east. So I just imagine as if I started from the x-axis and then I slowly brought it up to come to that angle that I'm looking for. So if I went upwards from the x-axis, well, then I have to say I went north, right? So I went up from the x-axis, and the x-axis is east. So I went north of east. Same thing if I were in the bottom quadrant here, right? If I was looking for this angle right here sandwiched in between the y-axis and the vector, then I would think of myself starting from the y-axis and then extending it this way until I make that angle. So I just went east of the y-axis, and this y-axis here is in the south direction. So I went east of south for this angle, and then this angle right here, right, I went from the x-axis downwards to form that angle. So that went south of the x-axis, so south of east. Does that make sense to everyone with regards to the cardinal directions? It might be a little confusing, but it's very, very important for pretty much any of this vector stuff and figuring out directions. Make sense? Makes sense to everyone else as well. I only see two people kind of replying, but hopefully it makes sense to everyone else. But yeah. So, with that being said, right, we know that the x component of vector A is positive 7 meters, and the y component is negative 11 meters. So, in order to draw this, right, we'd have 7 meters like this. This is AX, right? And then this is AY. Say that's negative 11 meters. This is AY, and this is positive 7 meters. So then, if we're adding our vectors tip to tail, like I am doing here, so I have the tip of vector AX to the tail of vector AY, then I just draw my resultant vector from the tail of the first vector to the tip of the final vector. So I just take the tail of AX, connect it with the tip of AY. So that would be my resultant vector, right? And that's my overall vector A. So AX plus AY, right? Add those two together. Those will make up the components of A. Now, in order to figure out what A is, well, we have to realize what shape this is. This is a triangle, right? So, if I wanted to figure out the magnitude of A, we already got the vector drawn. Now we need to determine the magnitude. What is the value of A? We know AX and we know AY. We need to figure out what A is. Anyone have an idea as to how we can do that? Yep, excellent. Pythagorean theorem, right? So that's, let me draw it down here, a squared plus b squared equals c squared, right? And if we can translate that to the problem, that means ax squared plus ay squared will give us a squared, right? So a squared is equal to ax squared plus ay squared. And then if we want to solve for that, we just take the square root of the whole thing. A squared, the square root of that would just be a. And then this is equal to square root of ax squared plus ay squared. And we can essentially just start substituting in our values to get our magnitude for A. And remember, magnitude, that only refers to the absolute value of your answer. So, and technically this doesn't matter here. You won't ever get a negative because let's say here for a negative 11, right, if we were to plug that in for AY, well, it's squared, right? So if you multiply two negatives together, negative 11 times negative 11, you're going to get a positive answer. And so it doesn't really matter. You're always going to get a positive answer here for your vector. So this is why the second component it comes in, right? We need to figure out or indicate the cardinal direction, which will give us the direction of the vector. So we can get the magnitude via formulas and calculations, but we need to indicate the direction through our angle and our cardinal directions. So if we go ahead and solve this out first, we have ax squared, that's 7 meters squared, plus negative 11 meters squared, right? Like I said, it doesn't matter if you put a negative there or a positive, it's going to end up the same answer. Now, can anyone tell me what they got for the magnitude of A? 13, right? Excellent. So 13 meters for the magnitude of vector A. Now, we need to figure out an angle of some sorts, right? So this is up to you. This is the only section or any part of this problem where you actually get a choice in what you do or how to solve the problem. So you either have the option of figuring out this angle or this angle. Doesn't really matter. Like I said, if you were to choose this angle right here, this would be south of the east direction, right? If you choose this angle, it's going to be east of the south direction. So it doesn't really matter what we choose, but what's important is we choose one, and then we figure it out with the calculations, and then make sure the angle matches up with the cardinal direction. Because if you were to say, for example, like we can see that if this one is bigger, right? Let's say this is 60 and 30. This is 60 and this is 30. If we were to say that the 60-degree angle, if you said that was south of east, that would be wrong. So your angle has to match up with the cardinal direction. You have to say this is 60 degrees, this is east of south. This would be 30 degrees south of east. So you have to make sure that your directions match up with the angles, your angles match up with your directions. So that being said, anybody want to choose or suggest an angle that we should calculate? Doesn't really matter, like I said. We'll just go by popular vote. South of east. Going once. Going twice. All right, sold to south of east. We'll go south of east. That's going to be the easier one too anyway, because in that case, we have this angle right here that we need to figure out. That's theta, right? And so what way can we use to figure out the angle theta here, right? Can we use trigonometric identities? If so, what trigonometric function can we use to figure out that angle? So inverse tangent, right? So if we were to use inverse tangent, let me move it up here. So inverse tangent, right? This is going to give us theta. Inverse tangent of what? Tangent is opposite over adjacent, right? So if we take this angle here, we find the angle that's opposite to it, or the side that's opposite to it, I'm sorry. That's going to be AY, and then adjacent to is AX. So inverse tangent of AY over AX, right? That will give us our theta, and that's inverse tangent of 11 meters over 7 meters. Now, an important thing to recognize too is that when you're calculating using these trigonometric functions, and as Ellen suggested or asked, you would have to use the magnitude. You cannot use negative directions and whatnot, because that will give you an incorrect answer and it'll just mess things up. So whenever you're calculating sine, cosine, tangent, whatever it is, always make sure to use the magnitudes of whatever you have. Because, like I said, the reason why it's two components is because the angle will give us the angle, right? That'll just give us what the angle is right here. But then the direction is going to be up to us, visually what we can see based on the graph. Because otherwise, if you start including negatives and positives and all that, you might get an incorrect answer and it'll be confusing. So I would just stick with using the magnitudes of your x and y components when you're calculating with these trigonometric functions. So we will do inverse tangent of 11 over 7. And then can anybody tell me what they got for that? $57.5 degrees. Anybody else get 57.5 degrees? It's 7.5. Okay, we got two people who have 57.5. So far, that seems like it's the consensus. And okay, more people. Excellent. Yeah, 57.5 is correct. Yeah, 57.5 degrees. So we have our angle finally. Now we just have to indicate the direction, and we already figured that out before because we chose which direction we wanted to calculate the angle for, and that's going to be 57.5 degrees south of east. Alternatively, you can say, if you wanted to think about this coordinate plane as a clock, right, and this is your minute hand, hour hand, whatever, it's clockwise. So imagine if you grabbed this hand and moved it this way. You went clockwise from the positive x direction. I mean, that's another way you can do it. I personally prefer the south of east, east of south directions and stuff like that. Just because I can literally just say, okay, this is north, south, east, and west. And it's just easier because sometimes like this whole clockwise and counterclockwise thing, it'll come in very, very handy. And it's very important for another chapter, like, I don't know, 3-4 weeks away, maybe, with forces. And it's already confusing then, so I won't bother with the whole clockwise, counterclockwise thing now. So I will just stick with saying or including cardinal directions. So south of east, east of south. Pick one, calculate the angle, and then make sure everything adds up. And so if you were to pick east of south, it's just a matter of subtracting this value from 90, because we know this here angle is going to be 90 degrees. So if you take 90 degrees minus 57.5, right, whatever that is, that's going to give you the angle that is going to be east of south, right? Make sense? I think 90 minus 57.5 is going to be around like 32.5. Yeah, so 32.5 degrees east of south would be your alternative direction to that if you wanted to describe it that way. But yeah, we just have to pick one, go with it, make sure all the calculations add up. Sound good for part A? Any questions at all? Going once, going twice. Okay, all good. Alrighty. So for part B, right, it says the vector B has a magnitude of 11.2 meters and is directed 64 degrees west of north. See, this is why I'm saying that I would just stick with cardinal directions, because it's probably going to be the common, terminology that's going to be used in the problems. So vector B has a magnitude of 11.2 meters, directed 64 degrees west of north. We need to draw the vector B and also write it in terms of components. So we have to draw B, right? And then indicate components bx and by. So in that case, right, we would have to draw another coordinate plane here. No, that's horrible, but okay, we'll take it. This is positive y, positive x here, right? And yeah, our magnitude is 11.2, directed 64 degrees west of north. So we have to recognize, well, what is west of north, right? Which angle is going to be west of north? So we have north here, right? This is north, south, east, and west. North, west of north is just going to be like, okay, well, if you have north direction here and we go west of it, create an angle, this will be 64 degrees. So that's the angle in question there, right? So we can say that this is 64 degrees west of north because we just grabbed this north direction and we went west of it like that, right? Now, all that's left for us to do is then calculate bx and by. So this is b, this is our bx, and this is our by, right? We have the angle, we have the magnitude of b, because b is equal to 11.2 meters, right? And we need to figure out bx and by. So, similar to the previous problem, the written homework problems, all that, it's going to be a matter of looking at some trigonometric functions, right? So, anyone have an idea as to how we can figure out bx? Yeah, go ahead. So, yeah, I see what you mean. I see what you mean. So you have this angle right here, and your by is like that. Okay. So, you could do the 26 degrees. It'll give you the same answer. You'll be able to do the components the same way. It's just that in that case, then, if you wanted to do this where it's the by facing down this way, think about vector addition once again, right? So if I were to have by like this and I wanted to add bx to it, then bx would be like that, right? And then in that case, if I were to draw my resultant vector actually looks something like this, which is like totally off. That's just in terms of if you were to draw it as a vector. So I would just prefer to draw it based on what the problem said, but you're absolutely right. I mean, you can say this is 26 degrees. We can say that this is by and this is bx, right? And then you could figure things out. However, you would have to adjust your final answers to coordinate with what they had in the problem. The reason being is by in this case, like I said, is going to be negative, right? If you were to do the 26 degrees that you're talking about. Or actually, no, I take it back. What you can do is actually just go this way. So my bad. You can go bx like this and by like that. And you can have the resultant vector like this. Yeah, so never mind. That actually, yeah, you can do either way and that will work. And yeah, you don't have to adjust your values or anything like that. So yeah, if you wanted to use the 26 degrees, go ahead and do that. You'll end up getting the same answers for by and bx. But yeah, so yeah, I would just... Yes. Oops. Well, there goes the answer there. But so yes, I believe both answers would be acceptable because the thing is here, what they're asking you to figure out is just the components bx and by, and they're going to be correct regardless of what angle you use because 26 degrees plus 64, that's going to give you 90, right? So either angle you use, as long as things kind of make sense with your sine and cosine, because if you do, for example, if you wanted to figure out by, right? If you wanted to figure out by, then you would do like, you would use the sine function, right? Because this is opposite the angle here. However, if you wanted to figure out by using the 64-degree angle, you're going to be using cosine because it's adjacent. So as long as all the trigonometric functions all match up, right? Either way is perfectly fine. But in terms of drawing the vector itself, I would just stick with drawing it with whatever answer that they have, or whatever, degree that they indicated or direction that they indicated, 64 degrees first. And then if you want to do the 26 degrees, you can do that. That's fine. But I would just make sure that you have everything that they require from you first. But either method will work, and I can show you that here in a sec. Yep. So someone already said sine, right, to figure out bx. So if we were to use the if we use the 64-degree angle, right, we have 11.2 is the magnitude. So bx over, let me go back to the red pencil here. So bx over b, right, so opposite over hypotenuse, that's going to give us the sine of 64 degrees, right? So if we want to multiply b over, we're going to get bx is equal to 11.2 sine 64, as Ellen mentioned. So for bx, we should get somewhere around, 10 meters for that answer. And then once again, we'd have to adjust our final answer for the direction that we're looking at, right? So since this is in the negative x direction for bx, you have to add a negative 10. So this right here, 11.2 times sine 64 is only going to give you the magnitude. The direction is up to you to recognize that I'm in the negative x direction, right? So you have to add a negative 10 there by yourself. And then for by, what function are you going to use for by? Cosine, right? So by over b is equal to cosine 64. B is 11.2, so by is equal to 11.2 cosine 64, right? By over b is going to be adjacent over hypotenuse there. So 11.2 times cosine 64 is going to give you what? What did you guys get for by there? $4.9. Yep, 4.9 is about what I got as well. 4.9 meters for this, and negative 10 meters for bx, right? And that's about it for that problem. And then going back to, I don't know who asked the question earlier, but basically, if we were to do this with a 26-degree angle, if we wanted to figure out bx, right, it would be cosine 26 degrees, right, times 11.2, and that would give us bx, and then by would be equal to 11.2 sine 26. And if you want, you can go ahead and calculate that out and check your answer. See that it matches up. Make sure that my math is correct as well. And once again, because the direction, the final answer, like what if you have negative or positive for your bx or by, that's going to be determined by the cardinal direction that you're in. So if you're west of north, well, west is negative x, right? And north is positive y, right? So that's going to be like your sanity check there. If they said west of north, right? Well, west is negative x and north is positive y. Even if they said 26 degrees, or even if you wanted to use 26 degrees north of west, right? Well, north, right? That's going to be positive y. And west, that's going to be negative x. So either one you'll see is going to give you the right answer, basically, in the right direction. So hopefully whoever asked that question, please let me know if like the calculations check out as well, and if all that all makes sense to you. As to, I mean, you can see as to why you can use either direction, because they're both going to add up to 90 as long as you have your trigonometric functions all in order, and everything makes sense. You're okay. Okay, awesome. Everyone good for problem 1? Any questions about problem 1 at all? No, all good. Okay. Alrighty. For problem 2 now, it is 2D motion, right? So we did vectors for the first one. Now we're doing 2D motion. So it says a dog is initially moving with a velocity 2 meters per second to the east, and then 5 seconds later, its velocity is 4 meters per second to the south. What are the x and y components of the dog's average acceleration over these 5 seconds of motion? Use the usual coordinates. East is positive x, north is positive y. So just looking by the points right here as well is a really important thing when you're doing these quizzes, especially since you're going to be doing them in person from now on. So if you see a problem with a lot of points or a few points, it doesn't matter. If there's any points for a problem and you have no idea how to go about starting it, solving it, whatever, I would literally just like start writing equations down. So it sounds pathetic, it sounds stupid, but if, for example, right, they're asking us for average acceleration, but you don't know what any of this other crap means, you can literally just write, okay, average acceleration, that's delta v over delta t, right? Boom. That's a point at least, right? Never leave your answers or never leave your questions blank, ever, ever, ever. Most important thing is to write whatever you know down. Even if it's literally just like the most basic stuff, anything counts for points, right? Like the TAs are grading your quizzes, so like first of all, they understand like your situation because they're students too. Second of all, right, especially when it's a lot of points like this, there's going to be multi-steps to the problem. So they might assign a point for getting the right equation. They might assign 2 points for having the right answer, right? Another 3 points for whatever steps there are in between, stuff like that. Or there might require like an explanation. So you might get points for the explanation. So like if you can explain what's going on, but you don't know the equations, you might get some points for that. If you know the equations, but you're not sure what's going on, you'll get points for that if you write something down. So just make sure to write something down when you're doing these problems. But going back to the problem, we have the dog moving initially. Let me actually do a smaller because I want to make space. So we have, this is 2 meters per second east, and then all of a sudden it's going 4 meters per second south. East and south, right? Well, there's actually two ways you can solve this problem. One is significantly easier than the other, but one of them is also, and this isn't the same one of them is going to be, I guess, in my opinion, makes a little bit more sense, especially when it relates to everything else that you guys have been doing for this chapter regarding vectors. So I'll go over the easy one first. And if it makes sense, it makes sense, and we can just keep going with that one. If it is kind of iffy a little bit, I can briefly go over the second example without going too much into depth into it, hopefully. But first of all, if we're moving with a velocity 2 meters per second to the east, we're moving 4 meters per second to the south, right? And they're asking for average acceleration over the 5 seconds of motion, right? Well, let's say this is some VI, right? If we're moving initially, so that's VI, and then we're ending our velocity in the south direction, 4 meters per second, that's like VF, right? So we have a VF, we have a VI, and we have average acceleration, right? So we know that average acceleration is equal to delta V over delta T, and that's VF minus VI over delta T, right? So we have our VF and we have our VI, right? Now, they're asking us for the X and Y components of the average acceleration. So they don't want us to necessarily put down the total, average acceleration just as the whole thing. They want us to figure out each component. So what does that mean? We want to figure out AX and we want to figure out AY, right? Now, we can clearly see and understand why there's a separation between these two values, and that's because initially we're only moving in the X direction because we're only moving east, right? There's no southeast, northeast, we're just moving in the east direction. And then all of a sudden for VF, for our second component, we're only moving south. So AX will essentially just consist of this point in time, right? This initial velocity, and AY will be dependent on this velocity, basically, if that makes sense. Because this is in the X direction, this is in the Y direction. This is east, and this is south, right? So that's how we're gonna break it up, essentially, right? Now, for AX, right, we know that's VF minus VI over delta T, but this is X components that we're talking about, right? So how can we adjust this formula here to specify more which VF and which VI we're talking about? Because remember, this is X and Y components, right? How can we adjust this equation? So if we just say VF and VI, right, that's giving you like, okay, this is the total final velocity and the total initial velocity and all that. But if we want to go by components, how can we adjust the equation to factor in the components? Yeah, exactly. VFX, VIX, right? So that might be a little bit of a confusing question, but when we're looking at components, we always have to make sure that our little subscripts, right, match up with the component that's in question. So VFX minus VIX over delta T. And you'll see why this is important here in a second. Because what's my final velocity in the X direction? Zero. Excellent, right? Because am I moving in the X direction finally at all? Because if I think about it, right, if I moved east and I went south, well, let's say I ended up here, right? Did I end up finally moving, right? Okay, or say, for example, we extended this 5 seconds to 10 seconds to 20 seconds to infinity, right? Am I moving in my final direction? So say if I extended this time to 20 seconds, after 20 seconds, without any change to my direction, is there any final X component to my velocity? No, right? I'm solely moving in that south direction after those 5 seconds. right? So VFX is 0 meters per second because we're no longer moving in any x direction, we're only moving in the south direction. So the x component of our final velocity, right? Are we moving? The x component of final velocity is just basically a question of whether we are moving or contributing to the velocity in the x direction. And since we are only moving south, we're not moving east or west, we're not contributing to the x direction or the x component of the final velocity. So 0 meters per second for VFX. Now, how about VIX, the initial velocity in the x direction? Do we have an initial velocity component? Yes, we do. So that's 2 meters per second, and that's east, right? So this is east, it's going to be positive, minus, if this was, say, for example, 2 meters per second west, then this would, the VIX would be negative, right? Because east is positive x, and west would be negative x, north is positive y, south is negative y. So VIX, if that was 2 meters per second to the western direction, right, then this would actually be negative 2. So your setup would have to be 0 meters per second minus negative 2. So it would be plus 2 in the end, 0 plus 2. But since we're in the east direction, we keep this part here positive, right? So this is 0 meters per second minus 2 meters per second. And this is over 5 seconds. So there's that setup there. And then this is VFY minus VIY again over delta t. And now, do we have the final component to our velocity in the y direction? Four, right? Excellent. So we're moving 4 meters per second south, and we have to add a negative here, right? To our VFY, we have to add a negative 4 meters per second because south is negative y, right? So if we're moving south, we're moving in the negative y direction. So we have to add negative 4 meters per second. And then do we have a component for our VIY? Is there some initial velocity component in the y direction? And by initial, we're usually referring to like the beginning of the time, basically, or beginning of time, or beginning of the experiment or whatever, right? So it's 0 because we started off completely initially moving in the east direction. We did not move in north or south at all. So our initial velocity in the y direction should be 0. And this is over 5 seconds as well. So this gives us negative 2 over 5. That's meters per second. And this is negative 4 over 5 meters per second, right? So this is about, what, negative 0.4 meters per second squared, and this is about negative 0.8 meters per second squared. Does that all make sense for our average acceleration value? This is negative, by the way, here, and this is negative there. So yeah, that'll give you the components of average acceleration, AX and AY. So if it makes sense for everyone, I won't go and give you the details of the second way of how to solve it. Really, the second way is very, very similar, but it involves some trig, and it's just, it's annoying. Yeah, go ahead. Which one? For AX here? Because you're, think about, okay, so this is more kind of implicit in the nature of the problem, basically. So if I'm moving east and I went south all of a sudden, that's not an instantaneous transition. So think of yourself like moving in or driving around, right? If you're going to make a turn, I mean, unless you're crazy, you're most likely, in order to make that turn somehow, you're going to have to have some kind of acceleration that's going to be opposing your motion, basically. Or you have to have some kind of acceleration that's going to help you change your direction, right? So if I'm moving east, right, my velocity is in the positive direction. If my acceleration is also positive, right, I don't know if you guys viewed my other written homework review sessions or not, but I went over this extensively, and this is basically thinking of this as like two forces, right? not really, but let's just think as velocity and acceleration as forces for a second here. So if I'm moving east, right, if I'm this brute force moving east, right, if someone comes up and pushes me, so if this acceleration comes up and pushes me in the same direction that I was moving, I'm going to go a lot faster. I'm going to accelerate, right? So if I'm driving around and I hit the accelerator, if I hit the gas pedal, I'm going to move faster, right? So if I was moving east, I continued to move east, and then all of a sudden I hit the accelerator, I hit the gas pedal, I'm increasing my velocity, right? And I'm continuing to move in the same direction as I was. So if my signs for acceleration and my sign for velocity are the same, it's an additive effect. So they get larger basically, right? So my velocity would increase because they're in the same direction, so I'd be speeding up. So think of this as just stepping on the gas pedal in your car when you're moving in the same direction. However, if they're in the opposite direction, if velocity is positive and acceleration is negative, if I'm this brute force moving in the east direction and someone comes to hold me back, right? That acceleration is negative, it's holding me back in the opposite direction of my intended motion, right? Then I'm going to be slowing down. So just imagine, like if you're playing a video game or whatever, and someone, right, if there's this big guy, right, there's this big boss and he's coming at you, and then someone holds him back or he gets obstructed in some way, right? That's going to be the acceleration moving the opposite direction, right, to slow him down, basically, right? So if I'm moving this east direction and I want to change my direction all of a sudden to south, right? Well, I'm going to have to hit the brakes. I'm going to have some kind of acceleration that's going to be opposing that direction, right, to slow me down, because I don't want to continue moving in the east direction, right? So I have to have something that's going to completely slow me down from moving in the east direction to basically help me transition to move only in the south direction. So if this was actually positive, then that would indicate that, well, if I was moving in the positive direction and my acceleration was positive, well, no way in hell am I going to start moving in the south direction now, because that would just mean that it would be an additive effect. I'd be speeding up at that point. Now, if it was negative, like we have it here, right, it would mean that I would be slowing down. So this is like, think of this as a stop sign, right? I stopped here eventually, and then I changed directions, right? So along this 5-second interval, I was stepping on the brakes, coming to a slow, not this one, coming to a slow stop, right? My brakes were working against the motion of the car. And then I eventually stop, change directions, move south. And that's why, well, if my direction here is 4 meters per second to the south direction, right? If it's negative 4 meters per second, well, my velocity is negative and my acceleration is negative as well, right? So it's like I'm moving negative velocity, and then here's this other force, this other person that comes pushing me in that same direction. So then I'm speeding up. So that's why I was talking about, like, okay, if we were to extend the time for this experiment, right? If we just let the dog keep moving, then for an infinite amount of time, for example, without any other interruptions, I would continue moving in that south direction, and I would just be getting faster, right? Because my velocity is negative, my acceleration is negative, they're in the same direction. I would just imagine this as if I was basically stepping on the gas pedal, kind of, just in the south direction. Yeah, go ahead. Mm-hmm. Um, Let me see here. So dog is initially moving with a velocity of 2 meters per second to the east. And so, yeah, that's a good question. It's a little confusing how they have it worded here. So, I would just imagine this as if, like, I'm not sure exactly how to say it, but because I can see what you mean where you say, like, okay, like, if he started off at 2 meters per second and then 5 seconds later he was 4, but I guess I'm trying to figure out the best way to kind of describe this. So the reason, I guess, why they want us to separate into components is to look at what was his initial, what was his final in general for the AX and the AY, or the X and Y directions, right? So if he started off at that beginning of the time interval, so like starting off 0 seconds, he was moving 2 meters per second already, right? Then that's his initial in the X direction. His final was 0 because he's no longer moving in the x direction after 5 seconds. So it's more like somewhere in between the 0 and 5 second interval, he made that switch of direction, basically. So let's say like maybe like 2.5 seconds, he changed his direction from east to south. We don't know if that happened or what time it happened, but basically all we know is that he started off east and he ended up south. So that's the whole like deal of the 5 second thing. Cause I know that it might be a little confusing, but we're only looking at initial and final. We're not looking at like kind of what happened in between. Because I can see where that means like, okay, if I were to think about this 5 seconds later, then I was moving 2 meters per second for 5 seconds. I can see where you might understand it in that way, but it's just telling us that if I started the timer at 0 seconds and he was moving at 0 seconds at 2 meters per second and I passed out for 5 seconds and then all of a sudden he's moving 4 meters per second to the south, that's what I'm trying to figure out here is what was his initial, what was his final. I really don't know what happened in those 5 seconds where I passed out, basically. That's kind of what the problem is asking. Does that make a little bit more sense? Okay, cool. Hopefully that is, I mean, that's a weird way of putting it, but yeah, hopefully that makes sense. Any other questions about 2A? Nope, going once, going twice. Okay, I will move on to part B. So part B is a bacterium first moves 6 micrometers to the east and then moves 4 micrometers at an angle 65 degrees south of east. Now it's asking us what is the magnitude of the bacterium's total displacement, right? So we have an x component, right? This is our x component here, 6 micrometers to the east. And then we have, this is going to be a combination of a x and y component there, right? Because it's 4 micrometers at an angle 65 degrees south of east. So we need to figure out the magnitude of the bacterium's total displacement. So let's label this, for example, vector A and vector B, right? So our total displacement, right? Let's say this is, it looks kind of like this. The graph would kind of look like this. A and then B is kind of like that, for example, right? And then our total displacement would just be our resultant vector, right? Because whenever they ask for total displacement and you have 2 vectors or 2 directions that we're looking at, our resultant would be our total displacement. So this C is essentially like our delta X, right? Or our D total, right? So do we have any Y component to A? Is there any Y component to A at all? 0, right? Excellent. So we're not moving in the Y direction at all, so it's all in the X direction. So if we were to look at AX and AY, AY is 0 micrometers, right? And AX would just be equal to the direction that's east, right? So that's positive 6 micrometers because east is positive X, west is negative X, north is positive Y, and south is negative Y. So now, how about B here? Do we have an X component for B? Well, if we were to think about this as if we did a coordinate plane here, right, and we looked at the direction of B, right, if we were just kind of draw this out separately here, so they said B is 65 degrees south of east. So if this is east, then we're going south, right? So this would be the angle right there. So this is 65 degrees south of east, right? And this is our B. So if we look at it here, is there an X and Y direction to B here? Or is it only Y or is it only X? What do we have? Yeah, x and y, right? So we have x here, bx, and we have by here, by, right? So, with that being said, right? Oops. If I wanted to calculate this c right here, well, up until this point, it's all ax. But what about this little sliver right here? What does that equal to? Well, that would be equal to bx, right? Would just be that little portion here. And the same for the y direction, right? Well, I didn't have any y direction for a, so all my y direction is going to come from by, right? That little decline there in position is going to come from by. So in that case, the vector c has cx and cy, right? There's two components to c, cx and cy. So cx is equal to ax plus bx, and cy is equal to ay plus by, right? In the same way that we think about vector addition, so a plus b, the resultant vector would be c. So overall, c is equal to a plus b vectors, right? And if you remember the other problems and the problems from the homework and all that, that's just the vector addition or the way that we describe it using vectors. However, when we're actually calculating the value, it's going to be a slightly different matter, right? Because in that case, we might need to do, Pythagorean theorem or something like that to figure out like the total displacement and whatnot. So does that make sense so far? Yes? Okay, awesome. So ax plus bx, we know that ax is 6 micrometers, right? We need to figure out bx. Bx, we can get that from a trigonometric function, right? So this is bx, this is by, right? What trigonometric function can we use to figure out bx? Cosine, right? So bx over b is equal to cosine 65, and b was 4 micrometers, right? So bx is equal to 4 micrometers times cosine 65 degrees. That should give us our bx. And then by will just be sine, right? By over b is equal to sine 65. Remember, cosine is adjacent over hypotenuse. Sine is opposite over hypotenuse. And that's opposite to the angle and adjacent to the angle when we're saying opposite and adjacent. So someone got 1.69 for bx. And for by is 4 micrometers times sine 65, right? So, and when we're saying 4 here, I have to indicate that correctly. Since this is south of east, east is positive, right? East is positive, so the x component has to be positive. However, the y component, since moving south, that has to be negative. So our final answer, if you get 3.63, it should be negative 3.63 micrometers, right? Because by is in the negative direction. It's in south direction, right? So you would have to check your cardinal directions to make sure everything makes sense. East is referring to the positive x direction. South is referring to the negative y direction. And so this is negative y, this is positive x. Then you kind of have to like relate that back to your components here. Your x has to be positive, and then your y, oops, I just want to zoom out here. Your y has to be a negative answer. So negative 3.63 and positive 1.69 for bx and by. So that being said, bx is what? 1.69 micrometers. And then we have ay here. Ay is 0 because we were only moving in the positive x direction. We're only moving east. And then our by, right, is the negative 3.63 micrometers, right? So this is what, 7.69 micrometers? And this is negative 3.63 micrometers, respectively, for Cx and for Cy, right? So that gives us Cx and Cy. Now, how can we figure out the resultant vector, the overall magnitude? Because these are just the components. How can we figure out the entire length of this thing? Any ideas? Yep, Pythagorean theorem, right? So this is Cx, right, because it's all in the x direction, and this is Cy, right? So we know that Pythagorean theorem is a squared plus b squared equals c squared, right? And so we can kind of translate that to cx squared plus cy squared, right? Those are the two components, right? Because we'll have, this is cy, and this is cx, right? So cx squared plus cy squared is going to give us c squared. We take the square root of everything. We'll get cx squared plus cy squared is equal to c. And then we just substitute these values in, 7.69 and negative 3.63, right? 7.69, and I'll forgo writing the units for now, just because I just want to make some space for it, the problem. And we have negative 3.63 micrometers squared, right? And that gives us our C. And then our C should be what? 8.5. Anybody else get 8.5 micrometers? No? $6.78. Do you want to walk me through what you have written down in your paper, just so I can see, like, maybe where you might have gone wrong? Because I got 8.5 as well. So I might have gotten the wrong answer. I just want to see. I would check to make sure that you have your negative, like, within the parentheses as well, because maybe if you have it outside, it might change things up a little bit. Okay, awesome. Yeah, no worries. It happens. So that's 8.5. Hopefully everyone else got 8.5 too. I know there's a couple people that joined a little bit late, so this stuff might be a little bit confusing, but it's all recorded, and I'll have the recording uploaded within like 10 to 15 minutes after this session. So you guys will have access to that both on YouTube and the Google Drive. But that's the gist of the quiz review. Definitely vectors are important. Know how to add vectors up, know how to add vectors, especially when they're, or actually know how to subtract vectors is important too, because if you have subtraction of vectors, right, it's going to be like addition. It's just that you have to invert a direction. So if it was if we were doing VF plus VI, for example, if VF was east and VI was south, for example, right, then that's how it added tip to tail. However, since acceleration, for example, is equal to delta V over delta T, delta V is then equal to VF minus VI. So if I wanted to subtract VI, then instead of adding it up like this, where it's east and south, then this VI has to be inverted from south to north. So if I want to subtract, I have to invert the direction. So VF minus VI is going to be like this, because then it's in the opposite direction than it was originally. So originally it was south, right? Then in order to subtract it, I have to invert the direction. So that's important for understanding how to subtract vectors. Cardinal directions and angles when you're defining the vector direction is also important. So figuring out if you're south of east or east of south, right, is very important as well. I don't know if anyone needs kind of like a refresher on that, but once again, if you look at my written homework review, I do like 3 problems of these in complete detail, every little step, and I like go on for like 5 minutes explaining the east of south, south of east thing, and all the cardinal directions and my principles for the directions of vectors. And also I did it at the beginning of this session anyway, so you can, if for forever came late, you could just kind of refer to the recording there, because I want to make sure to cover some other things here before I end the session. But that's basically for the vector stuff, what you need to know for the directions. Let's see here. 2D motion, really just, once again, it's kind of based on the vector addition stuff, but also making sure that you really fully understand these equations, average acceleration, how it relates to velocity. You're going to do the delta V over delta D for delta T, for example, right? And then outside of this quiz review, so let me move on to the online homework stuff, kind of putting things out. So in general, what's really important for this class, in my opinion, this is what helped me become successful in the class, is really focus on the written homework. In my opinion, I felt the written homework was kind of the golden standard, especially for the quizzes. And then for the written components on the exam. So your exams will have a multiple choice section and then some written responses. They're usually like 4 or 5 written questions that will look very similar to the quizzes and the written homeworks. And then your multiple choice will be kind of like a combination of like conceptual questions and very straightforward calculations. It's not horrible. Usually, like maybe there's like 1 or 2 really difficult like conceptual questions that you have to like really have had a lot of practice with the material and a very good comprehension, understanding of what's going on in physics. But once again, all that just comes with practice. Like they're not impossible problems or anything like that. It's just a matter of doing all of the work and making sure you're kept up with the class and the coursework, and you're asking questions and coming to the sessions when you need help and going to office hours and stuff like that. But the online homework, I'm going to be honest, like personally, I didn't review it a whole bunch when I was reviewing for exams and quizzes, because a lot of these online homework problems, especially like if you remember the one not from last week, the week before, I believe, like the very first online homework, there was stuff about like bacteria, like doing walks, and I don't know, stuff about like, in other words, to put it in the most simplest terms, they're very like medical centered and medical context type physics problems. So since this is physics for the life sciences, they're going to base a lot of these problems or kind of word them in a way that's similar to what you might see on the MCAT, for example, or what type of questions you might see on the MCAT. So the online problems, I feel like for the most part, especially like later down the line, you're going to get a lot of problems that are just very long-winded with a lot of parts, A, B, C, D, E, F, G, right? They're not by no means bad. They're very good at doing what they do best, which is giving you the concepts and making you understand the concepts. It's just for building like problem solving skills and like being familiar with what is going to look most similar on the quizzes and on the exams. I just feel like the written homework is the golden standard for that. So I would make sure to go and check out my written homework review session, do the written homework, look over it again, make sure that you're understanding everything from it and all that. Now, with the online homework stuff, really, they have a bunch of repeats. Problem 8 is really good for practicing your trig. So if you have a lot of problem with trig, I would go over problem 8 again. Problem 9 is simple, but very, very similar to it. The only added component is that they help you kind of figure out or practice Pythagorean theorem and recognize how to calculate like the final magnitude of a resultant vector. So I would go over problem 9 as well. Let's see here. Now, this is important too. Problem 5 is very, very important for building a conceptual understanding of how velocity and acceleration relate to each other on the path. So velocity is always tangent to your direction of motion. So for 1, for example, right? Well, I'm moving to the right, so my velocity is going to be tangent to the position, right? So it would just be moving to the right there, right? Now, my acceleration at position 1 would be 0. Because if, for example, I were to look at this as my position graph, for example, or if I were to think about this as just position solely, and I graphed velocity like this, well, over this little interval right here, I'm moving at constant speed, like they say in the problem. So if I'm moving at constant speed, right, then I don't have an acceleration at that point, right? So constant speed is different, or speed is different from velocity, because velocity is speed with a direction, right? Speed with a direction. So I could very well be moving at 2 meters per second along this whole thing here, right? But because I'm changing direction, my velocity changes, right? So I might be moving 2 meters per second east, and I change direction here. Now I'm moving 2 meters per second south. So if this was positive x and this is negative y here, this would be 2 meters per second east, and this is positive x, so this would be a positive 2. Now if I'm moving 2 meters per second south, right, south is negative y, that would be negative 2 meters per second. So I could very well be moving at the same like magnitude of speed or the magnitude of velocity, because the magnitude of velocity is speed. So magnitude of velocity is equal to your speed, right? So I could very well be moving 2 meters per second along the entire interval, but my velocity would be constantly changing along this interval just because I'm turning and, twisting and all that. So at 1 here, since over this interval, I'm not changing any directions, then if I were to do like a VF minus VI, for example, and say this was like over 2 seconds, well, if I was moving at 2 meters per second at the end here at 1, and I was initially moving at 2 meters per second anyway, well then, regardless of whether I divide it over 2 seconds, 3 seconds, whatever, then that velocity is going to be 0, right? And then if I think about it, well, acceleration is delta V over delta T. If the delta V is 0 because there's no change in the velocity, well then my acceleration is 0 as well. So that's why Jerry's acceleration at position 1 is equal to 0. Now, if I were to look at 2 here, right, there is going to be a change in direction, right? So there's a change in direction there. And so to change the velocity, right, I'm changing my direction, I'd have to have some acceleration. Acceleration, whenever you have like these curved turns, right, and you'll get to this like in a couple of weeks, maybe next week or the week after, I'm not sure. But essentially whenever you have a circle, whenever you're moving directions, right, so if I go from here to here on a circle, for example, or here to here, since the entire circle is curved, and I'm constantly changing directions, then my acceleration on any curved point is going to be like radially inward. So radially inward means if you were to kind of draw this as a circle, I'd be pointing towards the center, right? Radially inward. So if this was my radius, for example, of a circle, then I'm pointing that radius inwards. So I have to imagine that this is kind of a semicircle or whatever, or just any curved portion. The acceleration is going to be pointing inwards to that imaginary circle that you're drawing. So for 3, for example, then the acceleration would be kind of pointing this way, right? And we can check that here. Acceleration at position 2 is d, right? So d this way, right? So just imagine as you were drawing like a circle, I would point the acceleration radially inward. Same thing for here. I can't draw a circle this way, right? It'd be pointing into the curvature like that. You see what I mean? And velocity, like I said, is always going to be tangent to the position. So if I'm moving this way, then my velocity would look like that. This way, my velocity would look like this, right? So it's just tangent. So if you draw a line that's like literally just tangent to that point, then you get your velocity direction. So problem 5 is very important for this as well. Same deal for problem 4. It's very, very similar to it. Acceleration, when you throw something up in the air, for example, acceleration is going to be due to gravity, and gravity's acceleration is always pointing downward. So it doesn't matter if you're here, here, here. Acceleration is always downwards at every single point. So that's another thing to keep in mind. Some people get confused with this, but acceleration in 2D motion is always moving or directed downwards in the negative y direction. And then the rest of this is more of just like review with vectors. For the slides, this is another example of what I was talking about earlier, where you can kind of see that whenever you're in a curved portion, the acceleration is kind of directed towards like the middle of the circle per se. And this one is actually wrong. I don't know if Dr. Zhang or any of the other professors noted this, but your acceleration in this case, since once again, you have to think about it as kind of as a circle, your acceleration is pointing towards the middle. And they'll never like get really crazy with acceleration pointed kind of this way. I know some people will be a little confused about, well, why isn't the acceleration pointed directly towards the middle? It kind of depends, because like your curvature here is like very reminiscent like of a circle, but here it's kind of a little bit steeper, right? So the acceleration might not be pointing exactly towards the middle, but in general, it's always towards like the inside of the circle, inside of the imaginary circle, or inside the imaginary curved portion that you have. So yeah, that's an important part to notice here as well for the acceleration. And then, yeah, just making sure you guys have vectors down, components of vectors. I will see if I can make available this PowerPoint presentation on the Google Drive so you guys have access to that as well. But that's pretty much it. I don't think there's anything else that's hugely important that I missed. Mostly just vector addition, knowing and understanding the definitions as well between scalar and vector quantities. But other than that, we've pretty much gone over all the types of problems that will be pertinent to this chapter. So that's pretty much the end of the review. I've gone over the quiz, pinpointed the problems on the online homework, and pinpointed some important examples on the slides. How do we access the videos / supplies of your previous recordings? So I have a Google Drive link that I'll send you here in a sec, and a YouTube channel. Give me 1 second here. Let me pull that up for you. So here is my YouTube channel. The YouTube channel will just have the review sessions uploaded. So like this, oops, let me send it there. So there's the YouTube channel that'll have all the review sessions uploaded. And I'll have that uploaded like within 10 to 15 minutes after the session. And then here is the folder as well, the Google Drive folder, and that'll have any documents that I deem important or that I can share with students. And then also we'll have another link to the recorded sessions, because sometimes, if YouTube is down and you have Google Drive functioning, you can go to the Google Drive, or vice versa, so you have more than one place to access your information. But that's where you can find everything, and hopefully that's helpful. But yeah. Yep, no problem. I see, so Tay is left and Julian is left, or Julian. So any of you guys have any questions about any of this stuff, about online homework, about written, whatever? The written homework? Yep, 1 second here. Let me pull that up. written homework. Let me see if I can find it here. No, that's not it. I think this is the one. Yeah. This one, right? Mm-hmm. Mm-hmm. Yeah, I mean, this one is a little bit confusing. Someone actually asked a really, really important, very good question when I was doing their written review session. Um, but if you were to think about the initial velocity, and that's headed due south, right? So it looked like this, and then the final velocity is headed due east. So if we were to if we were to draw a resultant vector, it would go from here to here, right? So and that's very confusing to students because this would just really indicate like, okay, if we were to think about this like theoretically, if we wanted to figure out his final position, for example, then yes, he went from south to east and he's here now at this point, right? That would be like his direction. But we're concerned with the change in velocity, right? And therefore that will, I mean, later on we're trying to figure out the acceleration. So we're only concerned with like the direction of velocity per se. We're not concerned really with like his final position because theoretically his final position would be like somewhere around here. But um, we're only concerned with figuring out his um, delta v direction, right? And delta v is going to give us acceleration later on. So it's a little weird, but when we're doing like the velocity and trying to figure that out, we're going to stick with, okay, we have this is east, right? And if it was south for the final direction, we got to make it north because it's VF minus VI, so we have to invert the direction. Um, but yeah, it's kind of weird how it is all coming together at the very end, but that's the best way I can kind of explain it is that we're not concerned with his direction. We're concerned with the direction of the velocity, if that makes sense. Mm-hmm. Okay. Yeah, awesome. No problem. Did you have any other questions, or Tay, did you have any questions about the written or the online or anything like that? No, you're good. You're not lagging at all. Yeah. So it kind of depends on what angle you have that you're kind of looking at, right? So if I'm looking at this angle, tangent in general is not a matter of y over x or x over y. Tangent is a matter of opposite of the angle to the adjacent of the angle, right? And adjacent just means next to or touching, and opposite is just opposite to the angle. So if I'm looking at this angle, if this angle is the one in question, the side that's opposite to it is this one right here, and the side that's adjacent to it is this one right here. So if I was looking at this angle, I want to do Vy over Vx to find my tangent. Now, if I was looking at this angle, right, well, the side that's opposite to it is Vx, and the side that's adjacent to it is Vy. So in that case, it would be Vx over Vy if that was the angle in question right here. Does that make sense? And same thing for sine and cosine as well. Like if I sine and cosine, so sine is opposite over hypotenuse. So if I have this angle, opposite is this one, hypotenuse here, right? So I take Vy over delta V. But if I did this angle, sine would be opposite over hypotenuse, so it would be Vx over delta V. Does that make sense? So it just kind of depends on which angle is the one in question, and then you kind of adjust based on SOHCAHTOA, which is sine is opposite over hypotenuse, Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Make sense? Yep, no problem. Any other questions? Question 2. Okay. So that, yeah, that's like the question of the week, honestly. So, I'll try my best to re-explain it. Um, but yeah. So you said you already watched the video on this part? Okay, cool. Um, yeah, absolutely. I mean, here you're going what is that? VF, right? No, that's my bad. VI. VI is south and VF is east. So if you're due to tip to tail, your resultant vector should be down here. I'm guessing that's what you had as well, right? Mm-hmm. So that would be an indication of like the final position. Because like think about this as okay, if I was moving 2 meters per second, or let's just I'll keep it with the problem. So 12 micrometers per second due south, I'm moving this way, and I change directions. I'm moving 5 micrometers per second east. Well, I covered some distance, and now here's my final position. So that adding up those two vectors normally would just give you your final position, but we're wanting to look at we're not concerned with the final position of the bacterium or the amoeba or whatever it is. We're looking at the change in velocity vector, and that um, therefore we're trying to figure out the average acceleration. So if this was VI and this was VF, right? So I want to figure out VF minus VI. In order to do that, I have to flip the VI vector, right? So if I want to add up VF and VI, it would have to look like this, VF, and then adding the opposite of VI, which is minus VI, it would have to look like that, right? So in that case, so yeah, since VF is south, right, that's the original direction, or my bad, VI, and this is VF to the east. If I want to subtract VI, right, then in order to do that, I have to flip the direction. So I have to go from south to north. So essentially, if I were to just grab VI like this and VF, right? So this is VI plus VF, right? If I wanted to add VF plus VI, which is literally the same thing, I could literally just shift over VI and make it look like that, right? Now, if I wanted to subtract VI, I would have to flip the direction and make it look like this, right? Because I go from south to north. So on the graph, it would look like, because this was south initially, and this was east, right? This is VF. So if I wanted to add things up, VF minus VI like that, right? So I have to go from south to north. Then if I were to add it up in that same quadrant, it would look like this, VF and then VI like that. And then your resultant vector would look like that. However, I mean, your resultant vector isn't at the origin. So think about it as if like, okay, well, since it's not at the origin, I have to shift things up to the origin. Mm-hmm. Yeah. Yeah, that it's very, yeah, it's very weird, but yeah, I mean, that's how you would have to do it. Let me think about something else here. So we're moving initially south, then we go east, right? Hmm. So average acceleration, we had that as 2.17 micrometers per second squared at the very end, right? So, okay. I'm just trying to think of like some other way I can explain this. Um, in a better manner, but give me a sec here. Okay. I'm wondering, okay, if I was moving initially like that, VI and then VF, right? I have some acceleration in the y direction for VI and some acceleration in the x direction for VF. Okay. Yeah, honestly, I'm not 100% sure if there's a better way to kind of explain that, other than that we're concerned with just the direction of the velocity and not the actual, like, final position. Because I guess, man, I hate to just kind of like say that there's no explanation for it, but okay. Yeah, go ahead. So like this one instead of this one? Okay. Okay, so like, yeah. So like east of north instead of north of east, you mean? Okay, hold up. I don't know if you guys can see my screen properly, but let me stop sharing for a second and then reshare the screen real quick. Um, there's really, I mean, either way will actually work. You just have to make sure that your functions, like your trigonometric functions, all add up and make sense. Either angle works perfectly. It doesn't matter actually what angle you choose. It just, you have to make sure that your angle matches up with your cardinal directions, and that's it really. Can you guys see my screen now? Okay. So yeah, if you choose east of north, right? If I were to do inverse tan, this is Vx over Vy. If I did north of east, this is Vy over Vx. And like I said, I gave two options. You could either do 67.3 degrees north of east, right? Which would be this one right here. Or you could do 22.6 degrees east of north, which is this one right here. Doesn't really matter whichever one you pick. You just have to make sure the angle adds up and then the direction. So east of north, north of east. Have to make sure those two add up as well. Sound good? Yep. I don't know. I feel bothered that I didn't give a solid better explanation for the whole acceleration thing, but or the drawing of the vector. But really, that's really the best way I can kind of explain it is really just kind of like the whole idea of vector addition, making sure you're able to add the vectors properly. And so if you have the VI here and VF like that, if I wanted to do VF minus VI like they have it here, then I would have to flip this VI, make it north, right? So if I added like this would be VF minus VI, this portion right here. But that'll give me a resultant vector that looks like that. So kind of everything has to kind of shift upwards to match here. And so, I mean, yeah, I would make sure to pay attention to this. But generally with the quizzes, they won't do something that's a little bit more confusing like this, because they'll usually say like, okay, had to do north or something and then east. So like things will generally be in the first quadrant. But if that happens, like that they give you something like this, now you know how to kind of adjust for it. I would just make sure that if something like this is VI and VF is in the fourth quadrant here essentially, then if I'm doing VF minus VI, VF minus VI like that, it would have to kind of shift upwards to the first quadrant, so above the x-axis. Now, I guess if you have VI, VF like that, and I mean, I'm talking and trying to give an explanation, and I'm really just kind of just trying to do my best to explain it in the best way possible, because really, I'm going to be honest, I thought the exact same thing when I did this. Like I remember, I mean, I didn't get this wrong finally because I went to a professor and asked, and I didn't, get, I guess, or maybe I just didn't understand at the time, but really, that's how I kind of process things. It's just that we're concerned with the direction of the velocity, not the actual position. Because otherwise, if I did VI plus VF, that would be my resultant vector for the actual position. So that's where the amoeba would actually end up. But I'm concerned with the change in the velocity, so I want to figure out acceleration at the end. So VF was in the east direction, VI was south, and I have to flip that to be north to get VF minus VI in that case. Yeah. And what I'll do is I'll kind of think about this, I'll ponder it a little bit more, and if I can come up with a better explanation, I will like drop it in the Google Drive link and let you guys know about it. I don't know if you guys are in the GroupMe or not, but I'll see if I can come up with a better explanation of this and kind of adjust it. But for now, I guess I'd kind of take it at face value with this explanation for the moment. I mean, hopefully it makes sense enough, I guess, to where you can accurately solve the problem without too many issues. But yeah, that's the gist. I wouldn't, yeah, I wouldn't say like in general that's what you should do, but if you have a situation similar to this where you're ending up here somewhere, right? And you have to do this VF minus VI. You want to figure out your delta V. You're not going to be able to do that. Like, I guess. Okay. Here's how I would do it. Finally, I think this is probably a better way to explain things. If I'm calculating the delta V in order to find acceleration somewhere down the line, just don't start with your VI. I would start with your VF first, right? Because that's what you're doing first. You're finding the final velocity first, and then you're finding the initial velocity. You're subtracting the final minus the initial. So when you're calculating this delta v, when you're calculating acceleration with these vectors, right, I would start off first with your final velocity, right? So I know final velocity is east. And then I look at my initial velocity. Now my initial velocity was south. So this is VF plus VI in this case, right? Because I maintained my original direction, which was south. So when I do vector addition, delta V, right? If I want to do VF plus VI, I do tip to tail. VF was east, VI was south. So I'm maintaining the original directions. Now, if I want to subtract, if I want to do VF minus VI, I have to flip the direction of VI. So I go VF, and then I have to flip it to north to become VI, and that's where I get my delta V up here. So I think the best way to approach this problem or these types of problems, especially when you're concerned with something like delta V, I would do VF and then VI. Otherwise, like the rest of these types of vector problems, they're pretty straightforward, and you won't have to like flip things and move things around and whatnot. It's just that the issue here is with this VF and VI thing that you have to watch out for it and make sure that I would just start off with VF first, draw that, and then draw VI. So if VI was south, I would flip that to be north, right? Now, if, for example, let's say if VF was west, right? VF was west, and then VI was north, right? VI is north. Then if I want to do VF minus VI, then it would be VI south, like that. So then my resultant vector would be down here just for delta V, right? Now, if with that same example, if I went west and then north, right, then technically my final position is like somewhere around here, theoretically. That's why things are a little bit confusing. So just in the context of this delta V vector addition stuff, I would first start off with drawing VF vector, and then second, I would draw my VI, and then flip it, basically. Make sense? Yep. Hopefully that kind of stepwise is making a little bit more sense. But like I said, if I can come up with a better explanation, I'll try and I'll send it your guys' way. So that's a matter of looking at like the relative lengths of each one. And so if relative lengths and the angles. So if this was 30 degrees, right? I can't draw my 30-degree angle like this. That wouldn't make any sense. So I have to kind of draw the angle relative to its actual value. So if this was like 10 degrees, then that angle has to be like this, right? So your drawing might be a little off a little bit, but the way I kind of go about with these drawings especially is if my drawing's a little off, I do my calculations, and then I kind of try to adjust my drawing based on the calculations essentially. I don't think you're ever going to get something this complex on a quiz because there's a lot of steps and a lot of moving parts. Might be similar to it, but I don't think it'll be that complex. But like I said, just make sure that your angle is proportionate. Your drawing is proportionate to the angle, and then the length as well. So if this was 40 miles, this 40 miles has to be a little bit bigger than that 25 miles, right? I kind of drew it where it was maybe almost the same size, but you can see here then if I was looking at the angle, right? If it was 6.7 degrees west of north, that's not 6.7 degrees. That looks a lot bigger than 6.7 degrees. 6.7 would be more like here, something like that, very small, right? So you just kind of try your best to make your vector lengths proportionate and your vector angles proportionate as well. Does that make sense? And I think whoever asked the question about problem 2, they already left, so that's unfortunate. But no worries. I mean, I try my best to explain things, but I mean, I don't know. I've had like 3 or 4 people leave, or way more than 3 or 4 people leave, to be honest. But I mean, it's kind of up to them. And like I said, I'm available on GroupMe. You can contact me by email, and I'll try my best to get back to everyone. But there's only so much I can do. Yeah. So my email, and this is, since I still have this session recorded, it is MM, so M as in Mary, M as in Mary, A as in Alpha, S as in Sam, S as in Sam, O 4 at uic.edu. MMASSO4 at uic.edu. And yeah, there should be an announcement on the Blackboard pages for all the professors with the Google Drive link and with the YouTube channel that I have set up, where you can find all the resources and the review sessions uploaded. So hopefully everyone has access to that. And let's see here, what else did I want to say? Yeah, so my review session is 6 to 8 p.m. Sundays, Tuesdays, and Wednesdays. Sundays is written homework review, Tuesdays is quiz review, and Wednesdays an open session for anyone to come in and ask any questions. But yeah. Cool. All right. Any other questions? Tay, did you have a question? Yeah. So that, I mean, the angle, like whatever direction you pick doesn't matter. Like whatever you pick doesn't matter, but there is a difference. So east of north is different from north of east in that kind of depends on what axis you're starting from. So if I want to look at this angle right here, I look at the angle sandwiched in between, well, not this one here, my bad, sandwiched between the y-axis and the vector. So this angle is sandwiched in between the y-axis and the vector. So the way I say it, right, or the way I kind of describe that angle is I say, or I mention what direction that vector is, or what direction this point is here on the vector relative to the y-axis. I state that direction first, and I say of the direction of the y-axis. So if this, what this means is what direction here, or if I choose this point on the vector, for example, or this point, or whatever, relative to the y-axis, what direction is that? If I went this way. East, right? So if I moved east, I say east of the y-axis direction. So this is east of north, right? And I can think about it as if, okay, well, if I want to make this angle right here, I can start off at the y-axis and I can move east, increasing that angle until I get this big angle right here. And that just means I went east of north. Now, if I have this angle, right, I started off at the x-axis, kind of grab it as if it was a rod or something, or if it was a minute or hour hand on a clock, and I just twist it, turn it, pop it all the way upwards here to get north of east. So if it's the angle sandwiched between the x-axis and the vector right here, right? So that would mean I start off with the direction of the vector relative to the x-axis. So this is north of the x-axis. So, and then I state the direction of the x-axis. So this is north of east. This angle here, north of east. Same thing if I went down here somewhere, right? If I wanted this angle, what would this be? West of south, exactly, because you're moving, this is the angle that's between the y-axis and the vector, right? This is sandwiched in between the y-axis and the vector. So I go with what direction it is relative to the y-axis. So this is west of south, and this would be south of the west direction. Now, how about this angle right here? Yep, and this one? Yep, excellent. There you go. Yep, north of west. So there you go. That's the differences between the two. And so, like I said, whatever direction you pick, whatever angle you pick to calculate, stick with it and make sure that your trig functions all add up. So if I'm doing tangent of this angle right here, Vy over Vx, then whatever angle I pick, or whatever, I mean, if I do Vy over Vx, right, I'm going to get the tangent for like this angle. So then I have to say that this angle is north of east. If I do this here angle, it's going to be Vx over Vy. That's going to give me a different angle value. And then I have to state that it's east of north. So make sure that your calculations match up with the directions that you pick. Sound good? Yep, for sure. Any other questions? I mean, we have 2 minutes, so I mean, yeah. Yep, thank you, you too. And if that's all for everyone, we can probably end the session here. I can stop recording and that'll be the end of it. So hopefully this review session was helpful for everyone. And good luck with the quiz tomorrow.